Hello, everybody, whoever is listening in. Today we will have a talk with Leonard, who works at Volvo and has done some incredible nice work around MLOps and how to utilize cloud native projects to sort of superpower their ML initiatives. This is a cloud native Nordics event. As you can see, we are present in all of Nordics. Today it is the Aarhus group that is doing the hosting and has set up the events. In Aarhus we are Mike, who works at Humio, that just got sold for a lot of money, so congrats to them. Myself, I'm a CEO at a small company called Neospace. Then there's Kasper and Henrik, because they are now both working at Luna, so congrats to Henrik on moving from Pragma to Luna. Today, there's a guy that talks a lot, that's me, and then there's Kasper. As you can see, he's doing all the real work here, and is sort of our technicians for the day, so if we have a black screen, you can call him. Anyways, on the YouTube chat, you can ask questions. We will monitor it and collect questions for a Q&A afterwards, and enjoy.
Hello, can you hear me?
Hey, Leonard. Yeah.
Can you see me?
We can also see you.
Okay. I need to figure out how to share my slides nicely on this platform.
Yeah. There should be a share button, and then Kasper will do the magic behind the scenes.
Okay. Share screen. Okay. So unfortunately, I only have like one screen here. So I won't be able to track which slide is where or see you guys. So I hope that's not like a huge problem. But just tell me can you see the slides now?
Yeah, everything is awesome.
And it's on full screen.
Not full screen yet. Not totally full screen, at least. There it is.
All right. So anyways, thank you. And very nice to be invited here. And my name is Leonard Aukea. I'm driving the ML Engineering and Operations Initiative centrally at Volvo Cars. We're basically a new team. So they started a new part of the organization called Data and Analytics, and we're part of that DNA section. So yeah, oops, that was wrong. But anyways, our purpose is essentially to develop and operate tools and processes that accelerate and support all teams using advanced analytics and artificial intelligence. By the way, if you have questions or anything pops up like during the talk, that's also super welcome. I'll just answer them as we go by. There will be a Q&A at the end as well. But yeah. So just briefly, thinking that most of the audience are not working with MLOps, they are probably working with within the cloud native space and DevOps in general. So the main objective is essentially to make sure that we reduce friction, increase velocity, and ensure that we are deploying and maintaining robust and scalable and secure ML systems. And I guess this is a question many are asking, is DevOps MLOps? And I'm curious to hear what the audience thoughts are on this. Can I? Feels a bit awkward to not see anything, but I guess I just have to accept that.
So yeah, I guess we are the audience because we are streaming directly live. So I think Rasmus could probably answer this.
Yeah. So I think it's a good question, actually, and I think most people will tend to agree that it is in some sense. But I actually think there are some flavors to machine learning that makes it a bit special, a bit snowflakey.
Yeah, I kind of agree. I think what we need to start off with is convey like the differences between like traditional software and machine learning in general. And I guess like the differences in DevOps and MLOps basically stems from that difference. And I guess you guys have seen pictures like this in traditional software. It's deterministic. So you write the logic and you have expected behavior. And when you write tests and whatnot, you basically have tests that sort of make sure the logic aligns with the expected behavior. But software 2.0 or like machine learning and AI use cases, you basically learn the logic. So it's stochastic in that sense, or uncertain, and is highly dependent on the data. So I guess some of the reasons why machine learning is, I would say, hard or harder than traditional software is, yeah, we can skip this one, but obviously there's a lot of components that goes into and what encapsulates an ML system in itself. But the challenges, as I see them, is like uncertainty, as mentioned before, data, which is a huge dependency. So your ML system might require data from multiple different sources, and data changes, right? So machine learning is more of a sort of continuous process, and the behavior of your system changes with the data that is being fed into it. So going back to that issue is also reproducibility. So how would you be able to know how you should be able to trace back to what exact data was used to train which exact model in order for you to be able to reproduce your results in a scientific manner. And obviously you would need to, like in the real applied case, you sometimes need to do trade-offs when it comes to these aspects, depending on sort of the data sources and whatnot. But another, I would say, huge issue, which I have discussed before, is culture and collaboration in general. So many of the ML practitioners come from a research background and are not traditionally software engineers, but there's a lot of concepts from software engineering and traditional software that lends itself extremely well to the ML use case and is also like a high requirement. So there's a mismatch there, and it becomes complicated and complex to make sure that these different competencies, how to say, collaborate well with each other, or in certain cases are in the same sort of person. Yeah, the dependencies on different systems and basically data from these systems is hard. It's also harder to test for uncertainty instead of just doing like regular assertions and whatnot. Actually, in like real ML systems, I see it more as a sort of blend of software 1.0 and software 2.0. You need like both of them in order for the whole system to be complete. And yeah, another aspect is the need for extended monitoring. Like in traditional DevOps, I guess it's more like uptime, latency, and whatnot. Obviously, you can go to extremes here, and but you need to monitor like the inputs and outputs and of your model and performance and other aspects that sort of makes it a bit more complicated. And also worth mentioning, the resource requirements like on the infrastructure in terms of compute and RAM and whatnot is completely different. Like there are strong requirements in terms of like running batch workloads and whatnot. it does require a lot of RAM. You can think about the deep learning use cases, which is super popular nowadays. Any questions so far, by the way?
No.
I guess not.
Nope.
Or
yeah, just feel free to ask any questions within the chat on YouTube, and we will pass them through to Leonard. So
yeah, and I guess like when stuff doesn't really perform as it's supposed to, it's a lot harder to debug, because the sort of catching of where the error might be in machine learning is much harder than I would say in traditional software. So the search space for your bug is hard to find, and sometimes it requires a lot of experience, and you need to have a lot of visibility in order to get some nice clues onto where that bug might be. And also it takes a longer time usually to debug these, which you need to take into account. Errors are many times silent. Obviously you do whatever you can in order to sort of mitigate this, but let's say unless you are like monitoring the outputs and you have some sort of an expectation of what the output should be, like the system won't tell you that it's sending wrong predictions, and that is being presented to the user of the system, and yeah, just makes it complicated. And as mentioned before, it's harder to test in general, and there's more to test for, like data validation, data quality tests, model testing, regression for like, and these sort of aspects. It's sort of, you need to do this a lot more, and yeah, you need to monitor more. I would like to argue that machine learning is basically complex software in many cases. When you boil it down to when you're actually like applying and doing the work, there's a lot of similarities, but it's yeah, there's more to do. And one of the problems that we see is sorry, I haven't removed the logo here, but the problems we see is that many of the machine learning practitioners don't really have this grounding in software engineering, and are not like used to the culture, the tools, and the ways of working as compared to like software engineers. And it would be highly beneficial if they had these, because you need them even more in the ML use case than in the software engineering use case, I would say, traditional software use case. And we have practitioners that are not very well accustomed with Git, haven't worked on complex large code bases, collaborated together. And when you're basically on that sort of level, even if you like, let's say, nourish this team working on this ML project with software engineers and like DevOps like people, it's hard for them to even collaborate if you expect like a software engineer to like rewrite most of the code that a ML practitioner has written to train a particular model and whatnot. They don't really speak the same language and are not on the same sort of level. So I think it's good to find some common ground there. And with respect to that, at least at Volvo Cars, we're trying to set some clear expectations on ML practitioners that are like traditionally mainly from academia, to have some basics in software engineering best practices, also obviously mapped to machine learning. So maybe I jumped a slide too much now, but I wanted to present the sort of ML lifecycle. And if you're familiar with the software engineering sort of software lifecycle, it's very similar. Obviously, you do more of this like model development, model evaluation, and this training part that is sort of restricted to the ML lifecycle and gathering of data. So the way we have structured it at Volvo Cars is basically we have these states, I would say, in the release cycle, and we are trying to sort of convey them in terms of answering a particular question. And then we have a gateway, basically, where we do an evaluation if we should continue or not, or what the next step should be. But it's this basic cycle that the sort of ML project goes through. So yeah, in many cases, it's also we need to spend significant effort even understanding if ML is the right use case to solve this particular question, let's say. So yeah, I guess there's not that much to say about this. More in general, what you want to do is basically as quickly as possible, you should set up a continuous feedback loop so that you can make qualitative decisions on should you deploy this next model over what is already deployed. And you can't really make those decisions unless you have good monitoring, good evaluation, good metrics and whatnot. And you need to have all of these components sort of set in your infrastructure in order for you to be able to iterate quickly in an agile fashion. And that requires a lot of groundwork in the beginning, I would say. So our approach, basically, when I started at Volvo, there weren't really any talks about like ML operations. There weren't any sort of dedicated tools and services for machine learning in particular. We were quite early on in the sort of cloud transformation journey in this large enterprise, and I sat quite close to the team that were sort of reformulating the infrastructure for the connected car cloud. And during that time, we went like Volvo Cars invested heavily in going towards container orchestration in the cloud native stack. I will show you some architectural diagrams later on. So what we ended up trying to do is utilize that stack for the ML use case. And if you're familiar with microservices and machine learning, you would realize that it lends itself very well to the machine learning use case. It makes it also easier to integrate and for these particular teams to control and operate these individual sort of services. So we have at Volvo Cars, we have dedicated a dedicated infrastructure for the machine learning workloads, given that the resources required to power these ML systems and doing these batch training is vastly different from running, like, let's say, an arbitrary web application of sorts. And therefore, you want to set up your cluster accordingly with the right nodes and these things. We are also investing heavily in templating and reusability, given that, you know, ML practitioners don't really speak Kubernetes and are like, right as of today, maybe they can write a Docker file of sorts, but they're not familiar with like the Elastic Elk stack for logging or monitoring and what is Jenkins and these things. It's hard for them to like understand these concepts, and they are unfamiliar with a lot of the tools, even Git to a large extent, which makes it hard to automate a lot of the sort of or orchestrate the machine learning pipelines. So we're investing some time to try to bridge that gap between those two worlds. And given that we also want to glue what happens in Git with the sort of what happens in the infrastructure, obviously we have some expectation that the ML practitioners need to be confident in using Git. And obviously it's not rocket science. You can learn the basics quite quickly, and we have seen that to be a very promising approach for people to sort of collaborate more efficiently.
So, Leonard, there were a question from Dennis. I'm going to start from the bottom of the questions because he's feeling that in MLOps there is no champion tools. There is no one tool to do everything, but he's very interested in what do you use in your lifecycle and at Volvo. So.
Yeah, if we continue on, I will go into more detail about that.
Okay,
This
cool.
is these section of the slides is just building up to that. So
very cool.
I'm just
very
trying
cool.
to skim this through, but I'll try to answer his question during the slides that are coming, and obviously he could dig into more detail of those. But
Yeah.
I wouldn't say there's not one champion tool for it. That's my sort of quick answer.
That's
as of yet.
That's a very good answer. Henrik is also asking if you look at DevOps as not something you do logically, but you look at the value generation you do as, bridging development and operation, isn't it the same challenge with MLOps?
Well, in many cases, yes. It's I would say the sort of objective are vastly similar in that extent. It's just that I would maybe see MLOps as an extension of DevOps, given that the sort of requirements and the differences in the systems themselves, that sort of built-in complexities that you need to care for, which you maybe cannot expect traditional sort of DevOps engineers or DevOps practitioners to be like fully compatible or aware of. Like DevOps is also like I would say, cultural sort of philosophy that you obviously in MLOps you try to extend that philosophy, but you need to be familiar with the sort of machine learning lifecycle, the ways working in that sort of world as compared to like traditional software engineering, if that makes sense.
Yeah, I think that was a pretty elaborate answer, and it made sense to me at least. Thomas is actually asking a funny question because he wants to know where you find those MLOps engineers that can do Kubernetes as well.
Yeah, well, like in many cases, it can be like traditional DevOps engineers that have worked, like happen to have landed in sort of working with ML projects and ML initiatives because their sort of skill set was kind of required and closest to the needs. And then they have like become more accustomed to the ML use case in general. But yeah, I guess that, so obviously like DevOps engineers have like a good opportunity to transition towards like MLOps in that case, I would say. But even ML engineers that are like have worked for a long time with machine learning, like learning Kubernetes and the cloud native space, obviously there's a learning curve, but people are interested in that as well. Like I'm not very well accustomed to cloud native, or I have read like the documentation for Kubernetes like once or something. Like my background is basically mathematics, and I've worked as a data scientist and ML engineers for most of my time. I learned Kubernetes due to the need of us having some sort of a toolkit to deploy our machine learning models in order for us to provide value and automate a lot of the, like, how do you say, workloads that we did manually before, which took a lot of time. But I mean, it's not super hard. Like any human can learn whatever they want if they just are motivated enough, I would say.
Yeah, I actually think, to maybe elaborate a bit, we do a lot of work with customers that has the same question, and my answer is always they are like unicorns. They're pretty hard to find, and there's always a more sexy company to be in than yours. So, as Leonard is saying, maybe you should train them yourself. Find someone that is passionate and wants to learn, and then give them the space and the time.
Absolutely. And, infrastructure and things differ, and there are also cultural differences within different companies. So the way people do things, they might use very similar approaches, but there are small differences in between. I do believe in training, and obviously you should not hire unmotivated people. But yeah. Anyways,
yeah, there's actually more questions popping in, but I guess we will take them later, and then you continue a bit.
Yeah. Yes. Unless if you find some relevant question, I'll try to pop them in.
There's actually one, or maybe both of them are relevant, but Dennis says that regarding to roles, right, we have data scientists, we have ML engineers, maybe we have some people that's called MLOps now, I don't know.
Yes.
Are those MLOps people dedicated 100% to a team called MLOps? Are you doing something similar to SAEs where you sort of combine yourself into the ML teams or data scientist teams?
Yeah, so basically, I can only speak for how we do it. We do have ML operations engineers, we do have ML engineers and data scientists as well. In our sort of unit, we have become more of a central unit that works horizontally across Volvo Cars to sort of support and enable ML initiatives across the board. So we're popping in to help these out. And this ML operations team, and our team is consisting of ML operations engineers and ML engineers that works together. But obviously we are in very, very close relationship with the central DevOps team that manages all of the infrastructure at Volvo Cars as well. So we have like complete alignment on, let's say, when we do Kubernetes updates or when we update Istio, like the base vanilla stack is the same across the board. But in addition to that, we have some like other CI/CD patterns with the addition of CT and other tools and services that we maintain on top of that. But we do have it's close collaboration in a sense, and that's sort of how we work. And then we have data science teams that can also be combined with sort of ML engineers, and we work very tightly together to sort of depending on each project, we set up like virtual teams basically, and ensure that all of the sort of competencies are close together and they have aligned on like expectations and the way we're working, so that the communication becomes more streamlined, and therefore like the collaboration in itself.
Cool, thank you for that. I'll pop in later. Please continue.
Yeah, and obviously we try to evangelize like good principles. So we talked about like DevOps and MLOps being like a philosophy and a cultural aspect. There are like extensions to these things that should be in the minds of data scientists as well, where you like maybe traditionally a data scientist always wants to make sure that his model has the greatest amount of accuracy, but in a productionized setting, maybe it doesn't make sense to have like dependencies from 15 different data sources because this model just gets a slight bump in accuracy. Maybe if you can, you should like use a less amount of features, because all of these sources and features are essentially a risk factor. for the model to fail, because if let's say the data is corrupted from one of these sources, it will corrupt your machine learning system as well. And that's maybe something that data scientists and ML practitioners that haven't worked in an applied setting that much don't really think of, which is obviously a very important factor. That was just an example, but trying to have some like good guidelines and principles for everybody involved. So I guess here's a bit of an overview of. Can you see my mouse, by the way? I guess you can. So basically, as I said, we have transitioned to like a cloud native stack, basically on. I'm saying basically too much. I'm sorry for that in advance, but yeah. So we have a bunch of Kubernetes clusters separated by region and environment, and we have dedicated clusters for applications that speaks directly to the car, for example, and then others for like .com and other additional services, the app, and so building a car is much more than just a car. And then we have this dedicated machine learning cluster. As of now, we have vouched for using Kubeflow to a large extent, and I can. If you're not familiar with Kubeflow, what it basically does, I see it as a glue around multiple cloud native services. They offer like a unified UI and some abstractions for to make it easier for machine learning practitioners to sort of make use of the benefit of some of the services within the cloud native stack. So one example of that is they have this DSL called KFP that gives you the opportunity to specify your Argo workflows using Python instead of writing YAMLs to specify your Argo workflow. But Argo is the underlying power horse. You can use Tekton as well, but we're using Tekton for other things, which I will go through in more detail later on. But yeah, data scientists, machine learning practitioners don't really want to specify their pipelines using like YAML. So it provides some simplification and some other services around that. And then they have this unified UI, so you can launch like research environments or like notebook servers, run your pipelines, orchestrate your experiments and whatnot. I think this picture traditionally was aimed at showing how we want to sort of centralize our data via a Strimsy Kafka with the addition of like an Avro schema registry to make sure that we can consume that data and do operations on it, store it long term, and present it, and even like build machine learning systems on top of that, and make sure that our applications can consume from these ML systems. Maybe this is a good time to stop for questions. This one we haven't implemented yet, though.
Yeah, Emerson is actually a very interesting project. Maybe you can tell us a bit about that.
Repeat.
Yeah, so Emerson as a tool is pretty interesting. Can you elaborate why you want to use it and what benefits you see from it?
Yeah, so we haven't implemented Amundsen yet. We have just looked at it for a while. So it's a kind of a open source data catalog, and we wanted to have something for the machine learning practitioners and data scientists to have better control of what data they have to work with and what data is being fed out. One of the use cases we wanted to see if we could achieve is basically, could we potentially get the feature definition somehow referenced in Amundsen? So there's this buzzword of like feature stores basically having an online and an offline store, having clear definitions of your features so that you could reuse them across your machine learning models. Because in many cases, if I could take an example here, like there might be some relevant features coming from signals from the car that might be useful in across many different models. And instead of these siloed data science and machine learning teams defining their own features or redesigning these features, it would be good to have a central hosting for them. I think it's Lyft that started this Amundsen initiative, but it looks quite straightforward and simple. So therefore, we thought of potentially use it as an interface.
Yeah, and it's also customizable, so you can take it somewhat wherever you want.
Yeah, and I think the customizability is something that we have had in our minds during like a long time. But you could think of like Volvo Cars, hey, let's buy in this one-shot solution that solves like machine learning for us, or is this platform like, I don't know, Databricks or whatever. Like there will come a day where this doesn't suit us because we do have use cases. For example, think about federated learning where we have like models training in the car and we're getting weights updated, sent to a central sort of model in the cloud. And maybe we want to sort of extend or build out our platform and services to support this use case. I think like the open source sort of stack lends itself very well to that. So rather we would collaborate and contribute and extend according to our need than vouch for a sort of bought-in solution that always will have its gaps.
Yeah. Thomas is actually added with some good questions here. First question is, how do you handle distributed multi-node training? It seems like you're using Volcano, but what is your experience scaling up to maybe 100 trainings going on at a time? What pain points have you had you want to share?
Yeah, so we're quite early on. We have just recently got this system up and running in, I would say, MVP state. So we haven't had these larger sort of use cases with 100 trainings at a time. So we haven't reached that state yet. I'm hoping for that to change by the sort of end of this year or beginning of next year. So it's a matter of building up these use cases. But so far, Volcano have showed promise to us, haven't experienced any problems at all. And then, yeah, utilization of like MPI for these things, looks promising. I can't tell you where, when it fails or when it becomes a problem.
Cool. He also asks, what are you using for tracking experiments and maybe data lineage, which is a sort of a loaded term, but I guess he means the sort of life cycle of data and how it changes over time.
Yeah. So I guess there were two questions brought in there. So like, how do we track like versions of pipelines and experiments? We're using Tekton for a large extent. I will show you a more detailed picture for how we combine Kubeflow and Tekton. And for data lineage and data versioning, we are evaluating the use of LakeFS, which we used DVC before for data versioning, but it was not as good as we hoped. So
so my experience is good for smaller projects, good for the exploration phase, not really that good for production and more sort of teams doing it at the same time.
No, like same thing here. Like it works well if you're working like individually on a project or like small scale or some ad hoc thing or like, but not it doesn't hold for production, unfortunately. But the idea of having pointers and these things, I think it was quite interesting.
Yeah, and
Ideally,
maybe I'm sorry to interrupt, but maybe we should say that when we say DVC, it's called data version control, and it's sort of an extension of Git to control data.
yes.
Yeah.
Which is a quite interesting topic. And it's also more complicated than one would think. Like if you think of like GDPR and, deletion of data, if you want to be fully reproducible and have your history sort of intact, with these things in mind, it's a bit harder as well. And then obviously data is large and takes up a lot of space. And how do you make sure that you can store the specific versions of each data set? Obviously, you focus on the diffs, but in general, it's you could have a whole talk about data versioning in itself.
Exactly. Can you maybe just deep dive a bit on LegFS and what you're seeing and how it's sort of solving the problem in a different way?
Than DVC.
Mm-hmm.
So, like one of the aspects is that it shows more promise in terms of efficiency for storing this data, and it's more of a Git-like system, in my opinion. It has a nice UI, not that it really matters, but you have the concept of repositories. You have this concepts of like pre-commit hooks, post-commit hooks, where you could add in things like data quality. Maybe you want to use like great expectations for like basically built-in assertions for data. And I like that sort of overarching idea. And right now they're also working on an Hadoop-like file system for larger data sets to be stored in an efficient manner. So it lies on top of it can lie on top of Minio and S3. We're using Minio also, and yeah, it's interesting. I would say it's kind of alpha. It's Leonard Aukea, I think, is the CEO, and very, very nice people to interact with, and it shows promise, but a couple of steps forward. Right now, we're evaluating it, so it seems interesting so far.
Cool. Maybe just a quick question. Are you doing public cloud or private cloud when doing this?
Yeah, so right now, most of the things like within Volvo Cars, we do have like our own sort of data centers, our own like private clouds. We do have Google Cloud, we have Azure, we have AWS. Right now, our machine learning cluster is running on top of AWS at the moment, but we're not using what is it called? EKS, I think. So we're using COPS to build up our own sort of Kubernetes cluster. So basically, our ideology there is try to use it for infrastructure as a service and not so much the managed services. That doesn't hold for like, obviously we do have some RDS instances for data because maybe it's cheaper and they stand accountable and so whatnot. But
yeah. So maybe I don't know how many slides you have left, but maybe you should continue and then we can take some questions in the end.
Yeah, and I can go back to these slides later. So I don't know, this picture didn't show that much, but a little bit on the template that we have. I'll try to, here's sort of a directory tree of this particular template. So we're using GitHub to basically store our code. And we have a template which basically provides, according to us, some same defaults of how your project and how you should like structure your code and your workflows and what should be there. We have some built-in sort of use of PyTest, and we have basically a lot of the automation for like this project to be added to Kubeflow or the infrastructure. A lot of the CI/CD things comes from webhooks from what's happening in this template. And yeah, obviously it's a lot of overhead for the ML practitioners to get this structured well. So this is what we have come up with so far. We can go back if there's any particular questions about this, but it's mainly Python best practices, the automation built around those, making sure that tests are written, and yeah, also it's good to have this alignment. If multiple teams are using the same sort of things, it's easier for a practitioner to jump into another project or start working on another, and it's easier for like ML operations team or the engineers to bump in and help because he knows where to look for what and these things. So yeah, and we do have some versioning here, so you can upload Kubeflow pipelines, which are essentially Argo workflows, but they offer a sort of interface so that you can view, run, and you can get some additional output, see the logs and whatnot from these pipelines and these particular components. And we're using Tekton to automatically build and like each individual components, send the images to Harbor to make sure they are available for the pipeline, have these pipelines uploaded with the particular version and the particular sort of branch involved. So it's easy to track and go back in time to find which orchestrated pipeline has been running. And then this one here is basically the master branch. So I don't know where I found this quote, but the level of automation of data, ML model, and code pipelines is kind of a good indicator of the maturity of the ML process. So you have like basically a ladder here where you start off with a manual process and you have pipeline automation, and you based on a trigger from S3 you're retraining your data, and then you have like full automation where you actually start deploying your models. So obviously you need to have good quantitative metrics in order to make sure that make an automatic decision if this model offers an improvement over the existing one. So yeah, so coming back to this, so we're gluing Kubeflow, which is this unified interface, but it doesn't have any sort of CI or CD aspects to it in itself, and it doesn't have this data management layer. So how we're going about this is basically we have webhooks on the GitHub repository, and then we have a lot of Tekton pipelines and Tekton tasks to ensure that whatever happens in Git gets reflected in the infrastructure or on Kubeflow. And actually, we have been thinking about, there's this option to use Tekton to run the machine learning pipelines themselves, but by default, it's using Argo. But we're thinking about maybe changing to, but right now it's not an option, but we have thought about decommissioning Argo to just use Tekton because less tools to know and learn. Yeah, so this, I would say, tries to reflect the sort of development workflow, how we think about it from a kind of Git branching sort of perspective. So we have a master branch, we have a develop branch, and then we have feature branches. And from each of these commits, it might trigger some data quality checks, some standard software tests, some pre-training tests, upload these pipelines with different versions, and making sure the artifacts are being built, and fetching, obviously these components, like reusable components, which we have that you can use across multiple pipelines. That maybe, let's say we have one component that fetch data from LakeFS, and you just have a parameter of like, which is the address this data resides in, so it can fetch from the store. And yeah, we also have some nice slash commands that you can use on GitHub to trigger runs of these pipelines. And we're working on things that basically, why am I saying that word so often? But we have slash commands to be able to launch a notebook server, thinking about the sort of complexity of if you want to review a PR that contains some machine learning, an update to a machine learning model or whatnot, to be able to interactively go into the code and check into that particular commit to see what has been, like what there is to review. So there's this added complexity that many data scientists like to use Jupyter notebooks. I love it as well. And you're basically, sometimes you're committing these notebooks and it doesn't look nice in the diff. And when you want to review, you need to review like distributions, plots, and whatnot to make sure that you're making a qualitative decision. So there's like a lot more than just the code, one would say. Right now, we're using a tool called JupyText, which is essentially, it's just converting your notebook to a PY file with the percentage syntax, so the diffs looks nicer. But obviously, you can just create a Jupyter notebook out of that. And if you can launch the notebook server, you can also interactively run it to get the output and the results. And then we're pushing for things like saving your figures in this figure directory in the template. So you export your outputs basically. And you can view these on GitHub as well with the SVGs. And so it's kind of nice. But yeah, let me think here. So you have some experiments, you merge a PR, and it will run. Maybe in this case, I actually showed an example of like an inference service that would run in Shadow, and you get the live data that is being sent to the Shadow model as opposed to the model that is already deployed. This makes it like, gives you the option to see how your model performs on live data with actual users as compared to the existing model in itself. So that's kind of a nice approach. There's obviously others, but the challenges we've seen with implementing this was, first off, you need to have ML practitioners that are familiar with like Git workflow, and they build it into their sort of workflow to have reviews, which is super important given that you're working with these complicated use cases. And we're trying to automate as much as possible to make this useful. And it's also like within machine learning, you do model evaluation, you run in your testing set, but in a productionized setting, and for like the rest of the software, and like testing is not really a well-known obvious thing to do within the machine learning community to the extent that it kind of should be. And what we're basically trying to ensure here is, based on your monitoring and logs of your outputs and how your model performs in a live sort of set, what certain things should lead to. Let's say like your team identifies a failure mode of your model, the first thing that should be done is identifying like why this is failing. And when that identification has been done, you need to add sort of a regression test for your model, so that your next model that you plan to deploy during your next iteration needs to pass that test, so that doesn't by mistake have that same problem. And it takes quite a bit of work to get this workflow into the particular teams, but it's promising. In essence, Volvo Cars is well known for safety. We do a lot of testing of all of the components. We care about these things, and we should do the same thing with machine learning and our software. And a little bit on our roadmap is, I mentioned Lake FS, so that's currently showing promise, but it's in evaluation, and that's the closest thing we've found. We're using Knative eventing for quite a bit of work, but right now we wanted to use Knative eventing and CamelK to consume events from different sources that could trigger orchestration of certain experiments or training pipelines, retraining of certain models. And I think it's a very good project. And one problem that we see is that monitoring is quite unintuitive for ML practitioners, and it requires quite a bit of work to set up service monitors, and using the standard cloud native stack with Thanos, Prometheus, Grafana. You need to make sure you get these dashboards, these right metrics, given that you have a lot more to monitor. And obviously we want to make this more available for the ML practitioners, because even if you have MLOps engineers and DevOps engineers and whatnot, it's actually the data scientists and the ML practitioners working on the team that know their model the most, and the sort of monitoring, setting up metrics and what to monitor needs to be in the hand of sort of the owners of this model for them to continuously maintain their system. So we want to find a way to make that more available. I'm also curious if there's a more cloud native way to manage data. I don't know. Right now, we have tried Minio as an object store. It's supposed to be better for deep learning. It's just been more of a hassle to maintain, so we have fallen on using traditional object stores mainly. And I'm just curious what there is out there. So if you know any cool projects, or I'm just seeing that it would be kind of interesting to see more data being moved into the Kubernetes space.
Yeah, from my point of view, it's one of those questions we haven't really figured out the answer to, but there is a lot of things trending. But if you guys know out there, please just comment in the YouTube chat. I guess we're actually on time now, but Leonard, I hope you have 5 more minutes.
Yeah, well, I don't really have so much more. Basically, you're welcome to join us. we need people working for us. That's it. And
so
we can.
Let's run 5 minutes of questions and then we shut it down. So actually, I don't think we answered Thomas's questions or the question Thomas had from before, because he asks, do you use weight and biases in your stack or something similar to that for tracking hypothesis testing?
No, we don't use weights and biases. I've looked at the project. It has some interesting aspects to it, but we haven't incorporated it yet. But for experiments tracking and these things, we have this hyperparameter tuning engine that is built into Kubeflow called Katib. Actually, I'm sorry, I forgot to plug in my computer, so I have to move. Sorry about that. Yeah, no, I think it looks interesting, but it's also, yeah, I don't know. I haven't used it enough to give an honest opinion about it, but it looks
but
cool. But
we both understand the problem, right? That it's something about you do something explorative and you test a lot of ideas. Maybe you test different algorithms, maybe you test different data, and you want to sort of somewhere note down which pipeline is running, which experiment, and what were you expecting before you run it.
Absolutely, but you can do that with Tecton tasks and Kubeflow pipelines, and then using Katib for like tuning for testing different hyperparameter tuning. So I think we're basically solving for that use case.
Yeah,
to
that
some
makes
extent.
total sense to me. Makes total sense. There was a question around how do you monitor that models work, that they are healthy?
Yeah, well, I guess that's sort of standard. You have these health thing, and we have service monitors from Prometheus and whatnot. And most of our models that we're running, I forgot to mention that Kubeflow also has this other project called KF Serving, which is super cool. KF Serving is basically just offers a CRD of type inference service. It's an extension, I would say, of Knative serving. So the underpinning is a serverless Knative service, but it's adding some more sort of, let's say, inference-like abilities that are providing some same defaults so that everybody don't start writing like fast APIs and whatever it might be.
Yeah,
so
you're
you get
using
the standard. Yeah,
you're using KF Serving for everything?
Yeah, that's what we are trying to push for.
Okay.
Obviously, there are certain things there. So in the sort of online use case for online serving, or let's say that you have a system that sort of continuously trains based on each on one event at a time. So we actually have a guy in our team that is he's a core contributor to this project called River ML, which is also obviously quite interesting for the online serving case. KF serving is not really adapted to the online case yet.
Yeah.
But other than that, that's what we're pushing for.
Yeah. So last question, and I'm sorry if I didn't get to yours because you have a lot of questions. Maybe we should do more talks about MLOps and how ML in deep work. Last question is from John. He's asking, you had some slides about clusters and regions. How do you handling scaling out? Volvo is a big company. You are in a lot of regions.
Yes. So right now there's like China is a separate edge case. So we do have different cloud provider and have that as a region. So we have a region for the Americas, region for Europe, and then we have dev, staging, and production. And we have different clusters for each, which we sort of scale up and down, and have the central DevOps team is maintaining and monitoring all that's happening there. I'm not sure if that answered your question, but I think this is pretty like standard way of setting it up. Similarly, that's the approach that will be taken on the ML clusters. There's some key differences though as to the resources and to the underlying nodes based on the development cluster and the production cluster in itself. And because you might run experiments and a lot of the training in the development cluster, so it requires maybe more resources, whereas when you have ready-made models and whatnot, you maybe don't require that much. So there's some optimization to take care of there in terms of resource utilization and cost in general.
Cool.
Yeah.
That's all we have time for. Thank you so much for joining, Leonard. Can we share your slides with people somewhere, or do you still have them on LinkedIn?
No, I don't have these ones on LinkedIn. I can, these ones I just rendered through HTML, but I can share a PDF version with
Cool.
you guys.
That would be awesome. And thanks everyone for coming.
Thank you for listening, and just PM me if you have any questions or if something was unclear.
Yeah, Leonard is actually on the Cloud Native Nordic Slack and can answer in there if anybody has any questions. And I guess that's it. Goodbye, everybody.
Thank you.